All right, so welcome to migrating to IPv6, all right, using Windows Server 2008 R2 and Windows 7. So a couple of questions before we start, all right. First question, what does 0 mean? Off, okay, close enough. Anybody else want to take a try? Gateways? No, not what I'm looking for. The total number of IP4 addresses we have. All right. We pretty much ran out of IP4 addresses. All right. So as you can see now, what does that mean to us? Exactly. Beg your pardon?
They estimate to be about 4 billion IP addresses per person.
There you go. 4 billion IP addresses per person is what the estimation is. Anybody got 4 billion devices out at their home by any chance? Yeah, one person, excellent. Can we come and do some networking at your place? All right, so as you can see, total IPs. The last one there, anybody played with IPv6 here before? All right, okay. This session is not a pure 400 session, all right, because I anticipated that there will be a bunch of people that might not have worked with IPv6 before. So some of the sections will be more, level 2, 300, and then you will have your level 400 sections inside there as well. All right. So I just want to set that expectations up front there. So as I said, just a quick refresh. All right. So these are some of the things we have. All right. We got our local link addresses there. Okay. And you can look at your local link addresses pretty much as your good old private range of IP addresses, all right, that we have inside there. All right, so that automatically private IP address ranges that we have, that 169.254.xx/16, all right, that's what I'm referring to. So when I'm talking about a local link, all right, or a link local address, that's what I'm referring to if you want to convert it back to IP4 days. Your global, all right, that's pretty much your internet addresses. That's your 202.x.x or 201.x.x, all right. So that's pretty much what the global addresses are, and as you can see there, that's pretty much what everybody will get when they go into an IPv6 environment. Some more refreshing there, all right. So if you look at your private IP addresses, right, your 10, 172.192, that is now replaced by an FD00. All right, semicolon, semicolon. So anything in that scope there, that is the prefix that we have there, is going to be pretty much going to be a private IP address there. As I said, with your local link local addresses, already spoke about that. That refers to now as an FE, all right, 80, colon, colon, all right. So if you do an IP config currently on your laptops, all right, and you got IPv6 enabled on because you're running Windows 7, you should have an IP address based on that there, all right. Other things there, unspecified address, as somebody said so correctly a little bit earlier on there. Your ARP that we had there, now it's a neighborhood, all right, discover. And then the last thing there, of course, is your DNS records, all right. Now it's quad or A6 records, all right. So depending on which literature you read, some records you will see people talking about 4A records, all right, or Quattro records. Other people will say A6 records, all right, which refers to literally the same principle there. So when we start looking at the agenda, this is pretty much the topics that we're going to cover over the next hour. Right, so the first steps that we're going to go through is pretty much the design stage. The first thing we want to get into when you look at our environment is firstly design the IP6 environment there. You will most likely get a 48-bit subnet mask from your ISP. And then from there onwards, what you will be able to do is you will be able to break it up into smaller chunks, all right? So you can break it up into 52, 56, 60, 64, right? Depending on what you want inside there. If you go in and you do a DHCP, all right, and try and create a DHCP scope, Microsoft actually defaults you to a /64 scope, all right, if you set up a DHCP on a Windows Server 2008 R2 box. So as you can see, one of the big things there is the number of subnets, all right? Anybody going to run out of 65,000 subnets very shortly? Don't think so. All right. So what's going to happen is if you go and you just use the last set of IP addresses, all right, you will also have 65,000. All right, so that pretty much brings us back to the good old IPv4 address range that we had inside there, all right, and the number of subnets that we have there. So other things you can do now, because we have such a large number of IPs, is, for example, we can go, all right, set it, all right, and then say anything that is on 1, 2, 3, 4, 5, 6, all right, can be its own separate subnet. So you can set it up and break it up that way if you want to. Another option that you have there is go by location. So what I've done here as an example is that 4218, that is the area code of the convention center. So I've taken that, made it a hex value, which is 107A. So now, pretty much I can go, when I do my design, all right, and I look at my location, if I'm going to look at a per VLAN environment, I can now pretty much say, all right, any server or any machine that is in 107A, I know, all right, that is in the Gold Coast area, all right, or a particular postal code, because that's what it was there that I converted. So you can do stuff like that, all right, when you are thinking about designing your subnets out of components. The next thing is your number of numbers, IP addresses that you actually have there, right? So there are much more numbers of host machines per subnet than we have on the internet today. So to give you an idea, all right, if we take all the IP servers that's currently on the internet now, plus we take all the private servers from Microsoft, from Google, from Amazon, all right, we will still have enough IP addresses left over to do something with those. That's how many IP addresses we have available there for us. Right, as you can see, pretty much we have now 4 times 16 bits, all right, of IP addresses available there for you. So you can go and make your own calculations on the large number of IP addresses that we have available there for us. Other things that we have that we could do now, all right, is when we are designing it, we can go and say, all right, we want a specific IP address, and then the last set, all right, before we scan, we can individually assign IP addresses to a particular server, all right, or workstations, or we can go for a particular router, anything that is in the B:A/64 subnet, all right, that will be all my routers as an example, or as you can see there, all workstations, or all the servers there. So I can assign individual machines a specific IP address there. So when we look at the design from a router perspective, okay, the next thing, once we have decided, right, the number of IP addresses that we're going to have there, the number of subnets that we're going to have there, is we need to somehow start routing that traffic over our network. One very, very important thing is the fact is that the minute you get an IP range from your ISP, it will be a global range there. Which means if you're going to use that global IP addresses, you need to make sure that it is going to be secure in some sort of way there. Okay? Most people pretty much think NAT is going to give them security. All right, that's address translation there. You will need to have a proper firewall in place that you really make it secure. So what people might tend to do is they will go into a private range, all right, create their own private range of IP addresses and utilize that to try and segment them from the internet. All right. So as I said there, the global range is going to be a very critical thing that you need to take into account there. Don't be afraid of it there. All right. Utilize that IP addresses there. The next thing that we need to be aware of is all these protocols, all right, these tunneling protocols that we have available, our ISOTAP, our Teredo 64 side of things there, right? These are pretty much protocols that will help us during transition periods there. At this point in time, it's not currently heavily used there, all right? How many of you guys are still waiting for your ISPs, as an example, to support IPv6? All right. The rest of you guys are on an ISP that works with IPv6, I assume then? All right, good. Because there's a lot of organizations still out there that's actually waiting for their current ISPs, right, to get them over. So once you have got that there, right, then you can pretty much go into a native IPv6 environment. So when your ISP supports it, excellent. All right, but if your ISP doesn't support it, what then? This is where these protocols, your ISOTAP, your Teredo, and your 62V will then pretty much come into effect there. They will allow you, all right, to go through, all right, and then communicate from an IP6 environment to your IP4 environment on the internet and then back again, of course. One of the problems with these protocols, though, all right, is the people that went and design it, they're not basically doing really IP on a day-to-day basis. So what happens is now, when we do the translation, all right, because we're going through these tunnels there, it slows down the protocol. All right, because we're going through an IPv4 to an IPv6, all right, and then back again. So the conversion time does take a little bit longer. The protocol is taking a little bit longer to get the information back and forth there. And it seems like the network is slow. So the user is going to come up and say, hey, why are we so slow today? Why is the internet so slow? And that is one of the main causes, all right, of why it is going to be slow there. Now, one of the other things is inside there, something like direct access, all right, will utilize your ISOTAP, your Teredo, and your 64 there. If that is not a big thing for you in your business, if you're not going to use that, then pretty much you can switch those off and go purely to an IPv6 environment there. Right, so these are things that you need to consider, all right, when you are doing your design stages inside there. Other things that you need to be aware of is your prefix discovery, all right? So your prefix discovery is what will be assigned. It's pretty much like your IP addresses that you get assigned, all right, via DHCP currently in the IP4 world. So you will go inside there, all right, using a DHCP, and we'll say, all right, anything that starts with 2001, colon 1310 colon 1969, all right, as an example, those are pretty much my prefix, which means any machine that I send out, all right, or send an IP address will start with that there. And then thereafter, they will randomly generate it based on MAC addresses or other formats that you have specified. So the two ways of really getting that prefix out is going to be your IPv6 DHCP, all right, or alternatively is using your router there. Right, so when you're going to use your router, that is pretty much one of the recommended ways, okay, is because when the client boots up, the first thing that it basically connects to is going to be your router. And then from there onwards, the router will then give it pretty much the prefix it has there, and then your DHCP server, on the other hand, all right, will give it its DNS suffix, the DNS IP server addresses, etc. inside there. So what is the benefit about that there? Right, clustering. All right, currently in IPv4, we got maybe a 50-50 split, right, of IP addresses on two different DHCP scopes, right, or we have maybe an 80-20 scope split, right, etc. Now we don't really need to worry about that because our router will basically go out there, give you the IP address, right, and then it will contact your DHCP server, and that will give you then the DNS service and DNS suffixes, which means you need maybe one or two DHCP servers there, non-clustered, all right, and if anything happens, that's okay to one of the DHCP servers. There's always a second or a third one that will give you that information there. All right. So when we look at our IP6 design again, you know, the big thing that we need to do is try and keep it simple, right? The simpler it is, the better it's going to be for you. Now, I know everybody here is so familiar with the IPv4 addresses, and so am I. But we will get used to the fact that whatever the prefix is, all right, is going to be the mask that we're going to connect, or the prefix discovery side of things there, and we will pretty much pick up the rest of our IP addresses. That's why, if we go a few slides back, it is so important that when you start developing your subnets, that you understand, right, this is going to be all my workstations, or a particular section inside it. So, for example, if I go back there to the subnets, you could basically start off, all right, as I said, 2001, 1310, 1969, 107A, all right, and then say Great. We know that is pretty much the IP addresses, all right, for the convention center environment. Then we can go and say maybe 1 will be everything for servers, and then 2 could be anything for the workstation side of things there. So we have those type of things that we can look at. So we know anything that has basically a 2 : something afterwards, we know pretty much then that is going to be our workstations, or the ones is going to be my servers inside there. Now again, you can look at other things inside there at the same time and saying, all right, great. All right, I got now a 1, but anything that is in the 100 range might be my Exchange service. Anything that is in the 200 range is SQL, 300, whatever services you want to do. So you can go through that as an example. Right, question?
So does it only jump by 4 bits in the subnet mask?
That's correct, yes. It jumps up from 48, 52, 56, 60, 64. One of the other things there, if you're a larger organization, the ISP might give you a /22-bit subnet, right? But that's a huge environment there. Usually more the service providers will have those types, and they will then give you the smaller sections as well inside there.
So can you, in classes in Migrating, you still use a /50 to say everyone in this location, or do you have to be set to those /48, 52? So I'm meaning like access lists and whatnot. If you're doing internet routers or consolidated routing to different geographic locations, can you say /50 with this address is in Queensland, /50 with that address is in New South Wales?
It's better to keep it to the defaults, the 48, the 52, and etc. Than having to go further. You're actually just going to complex it a little bit more. Remember, we got a lot more IP addresses than NT4. Sorry, not NT4, IP4. So we don't need to really worry so much about the subnetting that we did there. So we don't have to run out, look at the calculator to determine exactly in what subnet mask we are in now. That's why when you look at it, it's better if you stick to that environment with your design. It keeps it simple. All right. So, all right. Any other questions? Right, as I said, also by answering the question, look at your growth. As I said in the Windows IP4 days, right, and we still have limited numbers. So we were really scarcely. No, that's not the right word. We were really making sure that we don't use unnecessary IP addresses on a per subnet basis, so we don't lose that much. Right now, we got so many IP addresses. We actually got too many. All right, as somebody said here, approximately 4 billion addresses per person. All right, so we can literally give an IP address to everything in the house, even in the wife and kids. All right, so as you can see, the growth factor is not going to be important now anymore. All right. So the next thing that we need to be aware of is my devices going to be ready? That is going to be your biggest challenge that you have in your environment. Right? Currently, your routers that you have, your switches, okay, can they run IPv6? Maybe you need to do a firmware upgrade. Maybe you need to buy new hardware in total there. All right. But it doesn't stop there. Yes, that is the first thing we think about. All right, but here's the next thing. What about your scanners that you have, your network scanners? What about your network printers that you have? Right, what about cameras? All right, a lot of security firms these days basically use IP-based cameras, right, controlling the environment there. So have you started thinking about those devices? All right. The other thing that we need to be aware of is our operating systems. So when we look at our operating systems there, all right, we might be using Windows XP at the moment. We might still be using Windows NT, all right? There is still some organizations that can't get rid of that NT box. You might have 2000, you might have 2008 R2, all right? Windows 7, Vista, etc. So it's going to be important that you look at that there. And then, of course, I don't think we all are just one provider, all right, from an operating system perspective. So you might have Linux environments, Unix environments, Apple environments as well that you need to support. Are they capable of running IPv6? So all these, right, is things that you need to make sure that you are going to basically be ready. Applications, that is going to be your biggest headache, all right? Network devices, quick and simple, right? Operating systems, quick and simple. Right, and we'll discuss the operating systems again a little bit later on. But as you can see, your applications is going to be the ones that is going to be really, really critical to you. Your current in-house applications, does it know how to talk over IPv6? All right, and as I said, we'll discuss some of that there. Now, very important, you got the IPv6 ready.org website. All right. Those are pretty much one of the standards out there. That's all right. When I go and pretty much look at the website, I can go and say, all right, is my current Cisco all right, router that I have capable of running IPv6? Is my current Nortel switches that I have in my network, all right, can that run it? My 3coms, all right, my Lucents devices, are they capable of running IPv6 there? So that will come back and say, yes, maybe it's been tested, all right, during phase 1, phase 2, all right. Maybe it's not even available. And we'll discuss that very shortly. All right, so the Ready program is definitely a place, all right, or a website that you want to go to. That will quickly identify your network devices and also your operating systems there. Right, but as always, if they're already, they get these lovely little logo, all right, IPv6 ready, pretty much like the Windows logo, right? Windows 7 premium capable, or what it was in the past there. The big thing though is, although a website tells you, yes, it is working, all right, it has been tested, everything there, it's still up to you to go and test it in your environment. Okay, so from your network devices, maybe you want to take some that you have there, all right, put it in a isolated network environment there, all right, in a test lab environment, configure it up, all right, and then start doing some testing from that device's perspective. Right, maybe you got your cameras, maybe you got your scanners, all right, etc. there. By default, most of the devices out there, from scanners, printers, and those type of stuff, I can tell you they're not going to work that well, all right? You will need to explicitly make sure that those devices support IPv6 there. Your applications, all right? Again, you will need to test your applications, all right? Stuff that is pretty much now starting to come out, all right, from the different vendors, okay, will support it. But again, to what extent will it support that application there? So you will need to look at it from that side. The last thing is our wonderful user. Okay, the user is going to be the person that you're going to have the most problems with. Because if you put them in a test lab environment, okay, and you say, right, let's go and test this machine, so right, so you've gone out there, you have disabled TCP/IP, all right, version 4 of course, and you're purely on an IPv6 and say, all right, go out there, great. They might be able to connect to the Exchange server. They might be able to connect to the intranet server, all right? And they will be able to browse to maybe some applications in-house. But when they go out to the internet, they might be able to reach Bing, or they might reach Google, you know, do a search, and then they click on the page. And then that page doesn't return anything back to her or to him. And why is that the case? It's because the page is IPv4. So it doesn't know how to come back to us, which is in a pure IPv6 environment. All right, if we're doing it in a pure IPv6 without the Teredo, without ISATAP, without 64 there. So you need to take those things into account, and you need to tell the user up front, look, certain things, all right, will be able to work. You know, you might be able to get to certain web pages because the organizations that host it has already been doing testing on IPv6 there. Anybody here able to read Chinese? All right, few people. If you go to a Chinese website, most of those websites are automatically on IPv6, pretty much since the Olympics. Right, they're one of the biggest adopters of IPv6. The rest of the Western world, not as quick as what the Chinese were with the adoption of IPv6 there. So just be aware. So when you do your testing, that your users, okay, is going to be aware. And then, of course, when they finished, all right, they've shown you where they're having issues with, what applications are causing the issues there. Great. Put them back on IPv4 and then go on there, fix the problems, and redo the tests, all right, over a period of time there. That's strange. The next thing, dual stack. All right. It will be the next thing that we're going to run for, all right, or within our environment. I doubt it if anybody's going to be able to go in one big bang over, all right, unless all the procurement was done beforehand. So we know already we have done all the testing, all right, we know that our applications, which applications is the problem ones, we know which ones, all right, we need to replace or upgrade, etc., the devices, etc., like that. Then we might be able to go in one big bang over. But most of us, I don't think the management is going to say, all right, there you go, there's $1 million plus, all right, get everything IPv6 ready immediately. So we will have that dual stack capabilities, all right, I would say at least for about 5-10 years, maybe even longer, all right. But someday, the day will come, we will be able to say, all right, that's it, we can now kill IPv4 totally. But until that day, we definitely, in most organizations, will need to run some sort of dual stack. All right, as I said, some organizations are still running NT4 because of certain applications. All right, and how long has an NT4 been out there? All right, 15, 16 years, take a few months in between. All right, so that's going to be one of the things that you're going to have inside there. So as you can see, this is going to be a classic scenario. You will have your IPv6 addresses, you will have your IPv4 addresses inside there. So certain applications will still use IPv4, certain applications will basically connect on IPv6 there. All right, and then at some point, we will then finally be able to say bye-bye. All right. Now also, having dual stack IPs, right, is not something that is really new to us. Okay, a few years, well, maybe a decade or so ago, we were running more than one protocol in our networks, okay. Some of us might be showing our age here by saying that there, but, you know, we had the days of NetBEUI, all right, as I like to call it NetFooey, all right. We had IPX, SPX, we had AppleTalk, we had TCP IP, etc. All right, so some organizations might have ran 2, 3, 4, or 5 protocols all at the same time there. All right. So as I say, this is not something that's going to go out of the door overnight there. All right. So we will basically be set up with similar challenges like we had in the past. You might find one machine going out there. It can access a particular application lightning speed, while another one might not be able to. So you might need to look at the binding orders, all right, look at maybe some other settings that is on that network card that's causing that there, maybe firewalls, etc. So we will have certain things, all right, in between there that's causing us sometimes to have little headaches, and we will have those headaches and that teething problem as time goes on. But it will become lesser and lesser, all right, as I said, as the time goes on there. So the next thing we got there is the operating systems there. Now, as I said, when you look at it, all right, again, we'll be going through similar things there. So at the end of this, all right, I'm actually going to do a demo. All right, so we're going to go through it. I'm going to show you what my demo environment looks like, all right. How do we go out there, test everything, etc. And then at the end of the day, we will get the IP addresses of IPv6 on there. Now, I'm not going to get rid of IPv4 on my environment at this point because I feel the majority of us, all right, will be in a dual stack environment, all right, for a period of time there. So as you can see, again, make sure you go through your designs, that you're IPv6 ready, that you are testing it, etc. So this is my demo environment there, okay. I've got 6 machines there. Pretty much I've got an internet server, all right, that will basically, we will connect to, that will host my external website. All right, so we want to basically connect to it via IPv4 and then IPv6 at a later stage. All right. We then basically have a TMG server for which I'm going to show you as part of a troubleshooting demo. All right, that could happen on a workstation, all right, due to antivirus, etc. So we'll discuss that a little bit later on. I got my Edge server, which is configured really as a router, okay, between my internal network and my external network there. Okay, so nothing fancy, it's just got routing and remote access on it. And then from that point onwards, All right, I got my normal domain controller. I got app 1, which is just a normal internal web server, Exchange server inside there. And then the last thing, of course, good old Windows 7. Now the link here at the bottom that I've put inside there, that is what I've used to set up my environment. So if you want to go back to your own offices tomorrow, or next week, or if you're really eager and you want to start doing some testing tonight on IPv6, this is where you can get these test guides there. Right, the test guides, though, I've used them as guidelines there, but I've still tweaked it for my demo side of things there. But they are excellent guides to help you with, if you want to check out direct access, if you want to do branch caching, if you want to do IPv6, all right, TMG, all those type of products, all right, is available inside there. You can download the guides, and it will show you exactly step by step how to go and set your environment up there, and then you can use it for testing purposes. All right. So in this example, all right, this is what my ISP has given me. All right, so I've got a 48-bit mask, all right, from my ISP there that I will pretty much use there. The next thing then is what I went and did is I broke it up into 64-bit subnets there. Note there that I'm using 1 and not 0, otherwise 48 and 64 would basically complain about the same basically being on the same network there. So I basically started off with 1, and also I've got only a single VLAN. Now you can always go in your test lab environment and add another VLAN inside there, or 2 or 3, as many as you want to for testing purposes there. Right. The next thing there that I've done, all right, and this is what I'll done is I will set up a router advertisement for my prefix there. So that will pretty much consist of my 2001:1310 All right, so pretty much that there will be my router prefix there. And then on my DHCP server, I've gone and set up my DNS suffixes, my DNS servers that are going to connect to. So in this case, I just got one, namely the domain controller there. So I've configured it there. And then lastly, this is what my network will look like. So as you can see, my ISP has got a 2001.002:/64, right? And that's what they pretty much is what I've basically set up my internal network as. All right. So as I said, the other thing that we need to go and do is look at our operating systems and see if they are going to be capable. Now note there, all right, that Windows XP is not currently supported and will not be supported either. Right. During no stage, all right, of the testing phases was XP ever tested. If you actually go and look closely at the XP IPv6 code, you will actually see it's still beta code. All right. Although it will accept and you can install the IPv6 components there and do basic functionality with IPv6, it's never been certified, all right, as for IPv6. The first product really to be certified is Windows 2003 server. Okay, and that was only during phase 1. And then what happens is also during phase 1, we got Vista, which was the first client one, and then also we had Windows CE 4.2 there. So that was my first client there. So they pretty much understand basic functionality of IPv6 there. And then more strenuous testing was done and was required for IPv6 there, and that's why there is a phase 2. So the phase 2 now, pretty much, again, Vista at that stage was the first operating system really that was tested from a Microsoft perspective, and of course Server 2008. And then subsequent, Windows 7, all right, and R2 was as well provided during that phases there. Now the way you can go, all right, and test this, all right, or check it out if your operating system is going to be capable of running it, is you can go to the IPv6ready.org website. All right, there's an option that says search. You'll click that there, and then you will say Microsoft or Unix or whatever operating system you want or whatever device you want there. You can then also see what phases. You can choose all phases, all right, which means it will search 1 and 2, or you can just search the latest phase, which is 2, of course. So you have that capability and then going out there and helping and identifying you and say, all right, great, I'm currently running operating software X in my business. It is not capable. What is the impact of being IPv4 compared to IPv6 if we have to upgrade everything now? Do we need to pay extra money, all right, to get those boxes up there, etc.? So these are things that you need to look at, all right, during that stages there. So what does it mean if I'm ready for phase 2? Windows 7 and 2008 R2, of course, is ready for phase 2. So what that means to me, all right, is the fact that they understand IPv6. They understand, all right, how to do router discovery, router advertisement, all right, neighborhood discovery, neighborhood advertisement. Right, those components are some of the critical components that we need to be aware of during that, while it's been tested during phase 2, to make sure that when we are communicating, all clients, all servers can handle those type of requests. Right, all the requests, not maybe one or two there. A classic scenario is like something like ICMP. Right, there's not just one ICMP command like, you know, the ping side of things there. There's lots of other components inside there. And I'll quickly, before I start the demo, I'll quickly show you that from a firewall perspective there, what I was meaning. So as you can see there, from the neighborhood discovery, all right, for your IP6 there, pretty much the stateless, all right, address auto configuration is some of the components that need to be adhered to in phase 2. That's why IPv6 phase 1 doesn't meet all these requirements there. As I said, your other thing is there, which I forgot to mention, is your DHCP version 6 client needs to be available there. Something like Windows XP does not support DHCP version 6. So which means you have to manually go and code a static IP address for each one of your clients. So good luck. All right, if you've got 5,000 users in your network. All right, imagine the typos that you're going to make there. We're all human, we're going to make some along the way there. And as I mentioned already, your ICMP version 6 is needed, all right, for clients, of course, to communicate inside there as well. The last thing there, okay, and this was not tested during phase 1, is IPsec. When you start looking at stuff like direct access, all right, and some of the other components that's coming out there, all right, and security perspective, that is one of the biggest components we want to make sure our client supports. All right, so we need to make sure that we have IPv6, all right, fully in phase 2 tested, and because it is, it will be available for us with IPsec as well there. When you, as I said, if you go to the website, the IPv6.org, ready.org website, and you actually go and do a search there, it will, the last 3 will actually come up and say, yes, it is IPv6 ready. Right, that will be a separate thing there, and will give you all the operating systems once again there. From a Server 2008 perspective, all right, we have our DHCP version 6 services there. All right, so it can hand out, all right, IPv6 prefixes, the suffixes, the DNS server IP addresses. So it has that flexibility inside there and can do that there. And of course, we got our DNS, all right, that is able to create our Quattro records or A6 records there. It can create our reverse lookup records for us as well. Remember, you will need to go and configure those, of course, on your network there. But this is some of the things that it needs to adhere to. So when you look at getting a number, all right, so I just want to get into a little bit more technical detail here about how we actually getting an IP address, all right, and IPv6 there. So I'm just going to make the entire slide bold there quickly. So as you can see there, Microsoft went out there and said, all right, how are we going to assign IP addresses? So yes, we got the FE80, all right, which is our local site, sorry, not local site, linked local addresses, all right. So we have that there. So Microsoft said, all right, we need to somehow tell people, all right, how you're going to get your own IP addresses, all right. So when we got the prefixes inside there, So Microsoft pretty much looked at it and says, all right, let's use the MAC address. Good idea, all right? But the problem is, it is 40 bits. We need 64 bits. All right, so if you look at a classic IP address, MAC address, there you go. That's your classic MAC address. So Microsoft said, okay, that's going to be a problem. We don't have 40-bit addresses. We need 64-bit addresses there. So what we will do is we will actually take it, cut it in half. That's what is happening there. And then what we will do is we will insert triple FE inside there. Right? So FFE. And then what we'll do is we'll flip a bit. The bit is not flipped by us as the administrators. It's flipped by the processing of the operating system and the generation of the IP address there. So pretty much the underlying level of the operating system. So that then goes, flips a bit there, and then what it does, it generates then an FE80 address as an example, and as you can see there, you got the IP address pretty much coming from that point there. All right, so there is my FE inside there. All right, so you then have that capability now. All right, so now we can then pretty much start communicating. And once we've got information like that there, our router prefixes, all right, we can now contact our routers, okay, or our DHCP servers, okay, and they will then be able to assign us our IP addresses, which we really want, which is our 2000, 1310, 1969 example that I'm using here. Right, so they will then basically be able to pick up those components, etc. When you look at the TCP/IP stack, right? Excuse me. This is what the stack looked like before Vista. All right. Note there, separate IP4, separate IPv6. All right. So we had two stacks inside there. All right. The reason why is because at that stage, nobody was really seriously thinking about going to IPv6 yet. All right, so most people were using IPv4, etc. Everybody was happy with that there. But then when Vista came out, SIR 2008 came out, Microsoft said, all right, now we need to start looking at it in a more serious fashion. All right, and they started to basically combining the two as one single stack there. Maybe 2-3 years, maybe a little bit longer than that ago, Microsoft had a lot of sessions at TechEd, right, webcasts, those type of stuff, all about the new generation stack. So what they have done is they literally have gone and combined the two as one. All right, we still have the capability of going inside there, looking at the IP addresses, all right, from an IPv6 perspective or an IPv4 perspective there. So you still have that flexibility in there. The big thing though is you can't go out there and say, all right, I just want to rip out IPv4, I just want to rip out IPv6 there. You can't. All right. This is why one of the big reasons everybody was complaining about, oh, how slow a copy process is between an XP box and a Server 2008 box or a Vista box to a 2003 box. It's because of the stack differences between the two there. All right, so those are going to be some of the things now that we don't need to worry too much about. So another thing that I just want to basically stand still on is pretty much the MAC address, the random IP addresses that we have there. So as you can see there, just want to make, those two little clicks needed to be pretty much under the IPv6 and the temporary IPv6 areas. Right. When I did my slides, they made a modification there. So pretty much as you can see there, all right. So because we are using the MAC address, all right, to get our information off our computers, all right, it is not going to be, or won't be that much of a difficult process, all right, to try and guess the information that you have inside there. So one of the big things is that we have is now, because of the way we are generating our IP addresses, all right, we can pretty much be followed wherever we go. So what does that mean to me? It means there that if I take my bags now, I head off to the airport. Airport has IPv6 capabilities. Great. Okay. I get to Brisbane Airport now, and from there onwards, go to the lounge, fire up the laptop. My IP address will be available to everybody because I'm using a global range. So now what will happen is, if somebody is following me, maybe a hacker is basically trying to find some information about a person, he then gets an IP address from me, all right? I then basically fly out, all right, to LA as an example. Get to LA, again, wait for my next flight to wherever in the US, and again, when I'm at the airport there, I fire up my laptop, and now he gets my IP address again. But this time, he noticed that I'm no longer in Brisbane. He now noticed that I'm actually in the US. And then from there onwards, if I fly again onto another airport, so let's say we're going to Atlanta, all right, and I open it up there in my hotel in Atlanta, the guy on the other side could start understanding and say, all right, great, this guy is actually traveling. Right, because of the reverse engineering that can take place, all right, on your system because of the MAC addresses that is available there, that could be an issue for us. So now he, all right, can actually start sending us advertisement information about, hey, you know, if you go to this hotel, you can get it, something like that, which is not good. So what Microsoft said is, this is not good for us. We don't want something like that there. So they say, all right, what we will do is we will give you an IP address, all right, which has a normal lifetime there, and then we'll give you a temporary address, which is a relatively short lifetime, valid lifetime IP address as well. Which means now, because I'm traveling and I'm going from one place to the next place, that is the one that will change, all right, every time I get to a new location. So nobody will be able to follow you that way, right? So it's a good thing, but it's also a bad thing, that the fact that we had this capability of so many IP addresses following us wherever we go now. Right, so what I want to do is just quickly go into a demo. Wrong place. That's showing up? Yeah, there we go. All right. So this is my Windows 7 box. But before we go inside there, I just want to go to the Edge server. I just want to open the advanced firewall security and just show what I was trying to explain a little bit earlier about the ICMP and all the protocols. Somebody's buying beers early. Right, so the first thing that I just want to show, as I said, it's not really part of the demo, but I just wanted to highlight out here is the ICMP version 6. If I go customize, right, this is what I meant. It supports all IPv6. And IP phase 1, that was not the case. We didn't support all these protocols there. So now I could say, all right, I only want to allow echo requests there. So in other words, if I do a ping just to see if the machine is up there, yeah, good. But if I want to do any of the other things there, like neighbor discovery, advertisement as an example, sorry, that is not going to be possible for me via the ICMP version 6. This is where phase 2 was so important, that we made sure we adhere to all those standards inside there. All right. So what I want to show you firstly is go ipconfig, all right, on my machine. Sorry, this is on the wrong one that I want to show you. On my Windows client, as you can see, all right, there is my IPv6 address. All right. And note there that it starts with the local link address itself there. Okay. But also notice that the client is also still at the same time a IPv4 client inside there. So the back end I've already gone and configured for IPv4, and I will quickly show you that. I'm not going to go through everything, I'm just going to go and show you the DNS. Oops, wrong place. So as you can see there's my DNS servers. All right, my DNS server. There's the IP address as an example for my app server, IPv4, IPv6, etc. there. All right. So coming back to my client, the next thing that I want to do is actually on my edge server, not the client, done an IP config there, and as you can see, I got my router gateway and set up inside there. So the next thing that I want to go and do is I actually want to start enable route advertising. Now this can be done right on your Cisco, your Nortel devices, etc. You will just need to run the appropriate commands on there. Now I don't have that here, so I've basically set up a Windows host, a router inside here. And I'm going to use certain commands there. Okay. The commands are pretty much used there for one, so I don't make typos, all right, and I know my demo is going to work. I don't want to troubleshoot too much. It is late afternoon. All right. So what we're going to do now is pretty much the first interface there. Going to run. Whoops. Paste it. And really what that does, as you can see there, it shows me my different IPv6 network interfaces that I have. As you can see there, I got 2 connected ones, all right? Actually 3 connected ones, but the 2 that I'm really interested in is my internet one and my corp.contasa.com one. My corp.contasa.com is, of course, my internal network. My internet is my external network to which I'm going to connect to. So the next command that I want to go and do is actually go and advertise, all right, my environment, all right, from my router. So I'm going to say there, set the interface, all right, as number 14. So where did I get that number 14 is from my index there. And as you can see, that is 14, my internal network. I could have, instead of put 14 there, I could have gone corp.contasa.com there. All right. The problem is 2 things I can't spell to save my life. All right. And 14 is much easier to make sure that everything will work straight off the bat there. All right. So you can basically either put the name itself there, all right, put it in quotes if you got spaces in there as well, or alternatively just put the number inside there, which I've done. The next thing there is what I've done is, all right, I've gone and advertised it on that interface. So on my internal network interface, I'm now advertising that I want, all right, the 2001, 13, 10, etc., all right, addresses being advertised to that network there, and I want to publish that. The next thing that I want to go and do is pretty much start the publishing process, all right, for my internal interface there, and also tell my router what the prefix is going to be there, as I said. The 4th one there, which is the one underneath there, that one there, all right, is pretty much used to publish default gateways. All right. Because IPv4, we always had the gateway itself there, okay? And now, pretty much, this one will go out there and then set the gateway settings in there. So what I'm going to do is, I'm going to run those 3, and then we'll come back to the last one. All right. So they have run, etc. So if I go back to my client now, I'm going to go ipconfig. I have now, as you can see, IPv6 temporary addresses inside there. All right. However, I've got a problem. It will work internally if I use it by IP address. If I go ipconfig, why is cap locks on? ipconfig/all. I got some really important information missing under my DNS side of things there. I have not received any DNS information there. All right. This is where the last command comes in that I have in there. So if I go back to my edge server and I look at the last command there, so what I was saying inside there is, all right, go out there, run that. So we say other stateful enabled. So anything else that I want to enable, like my DNS suffixes, my DNS service, etc., will then be available or be made available there for me. And I say, okay. But where is it getting this information from? You might have seen it a little bit earlier on when I went on my DC itself there. There's my DHCP server. All right, so what I've done is I've gone and configured that there. So if I just get rid of that there, as you can see there, there is the DNS recursive name server, all right, my search list there that it's going to use. So now, if the demigods are with me on the client, if I do an ipconfig all now, no, seems like they're not. All right, I would have had that information there. So what I'm going to do is, I'm just going to quickly restart this work server. Now this should not have happened because it worked perfectly on my machine, and once I gave my machines over, yeah. So in a couple of seconds, right, my machine will be hopefully up and running there. And if I run that again, I should have my DNS suffix from my IPv6 perspective, my DNS suffix as well from that point inside there as well. I've tried that a little bit earlier on before we actually started the session, and it did not work. And the only way I could get it to work was to restart the machine there. So I'm not 100% sure what changed from my environment until I gave them the virtual machines there. So yeah. All right. So if I go now, there we go. All right. So there's my DNS search suffix list there, the DNS service, etc. Now I will be able to go, ping a particular machine, etc. So if I go ping TAEU-DC1, there we go. IPv6 coming back. All right. So pretty much just the commands. I'll put it in the slides there so you don't have to quickly rush down and try to write it. All right, so there it is. So the next thing is migrating an application server. As I said earlier on, your application services is going to be one of your critical things that you will need to look, or your applications on a day-to-day basis. So you need to go through that process there. All right. So as you look at your TCP/IP stack, all right, etc., you're all familiar with the Aussie model, all right? So when we look at it, the people that developed, all right, the IPv6 there, they said pretty much, great. It's not going to be that difficult to migrate, all right? Everything happens at the network layer, okay? Yeah, I can hear the snickering going out here, yeah. You know where I'm going with this. There we go. We have our sockets, we have our sessions, we have our applications. They all use some sort of TCP somewhere along the line there. All right, and that's where your problems is going to start lying. I have seen people actually hard coding dedicated IP addresses into their applications. You change the applications or the IP address of that server, thank you very much, game over. All right. And that can take time to troubleshoot that. So these are some of the things you could run into, all right, as time goes on there. So as you can see there from a readiness perspective, once again, in the theoretical world, great, it's only the network layer, but in the real world, you need to look at your sockets, you need to look at your monitoring log files. That's going to be one of your other problems you're going to run into, because by default, some applications only log 32 bits of information, all right? So which means they're literally going to only do the first bunch of your prefix. So you need to start looking at that environments there. Other things that you need to look at is security. Right, allow and block lists might be available for IPv4, but might not be available for IPv6 yet. Right, so these are some of the things that we need to be aware of, all right, when we're looking into our applications. So when you look at something like IIS, all right, IS7, IS7.5, all right, which is the R2 release of Windows, right, they all support both TCP, both TCP IP version 4 and version 6 as well. The thing is, what we need to go and do is under our binding side, right, You will need to configure it for HTTP, HTTPS, of course. If you had, and that is natively out of the box for 7 and 7.5 there. Although, when you look at IP address and domain restrictions there, you actually need to go to the application host.config file in IIS 7 and configure it inside there. If you try and do it through the GUI, it's going to say to you, sorry, I don't understand what you're trying to do to me. All right? And it's going to yell at you. It actually says there also only IPv4. So, but if you go underneath the hood, so right underneath the covers to the application host.config file, there you can go and modify the XML file, all right, and then add in your IP addresses. In 7.5, all right, that's out of the box. It will accept both IP4, IPv6. Logging natively, all right. So you don't have to be concerned about, all right, only the first 32-bit of information is going to be logged there. Everything will be logged. The last thing there, FTP. All right, natively out of the box on iOS 7, you actually had to go and download FTP version 7.5, install it before you could use FTP with IPv6 there. And again, you can set the bindings. During the initial creation of the virtual directories, etc. like that there, you will only see your IPv4 addresses there. And then later on, once you have created it, you can come back and then, just like you did with the TCP IP, the HTTP bindings, all right, you will be able to do the FTP bindings exactly in the same manner as well. From an Exchange perspective, a lot of people say to me, well, look, Exchange doesn't work with IPv6. Yeah, right. Okay, if you go and disable features, right, or if you go and disable TCP or the IPv6 section, on Exchange server, you will have issues, and we'll discuss that a little bit later on when you look at troubleshooting. But that's going to be one of the big things there. But as you can see there, features that works out of the box, all right, is your IP allow list and IP block lists. Stuff like your sender ID, receive connectors, send connectors, they all are available, all right, and all currently working. As long as the other side has IPv6 enabled there, yes, it will work. But of course, if they don't, you will have issues. All right, and I think that's where most people say why it doesn't work. All right, it's because the people that they connect to might not have that flexibility. Also, mailbox servers there, all right? So if you go clustering, so the clustering components as well does support IPv6 during setup there. Right, they also support ISATAP, right, as well there. But again, one thing you cannot use is link local addresses when you set up your cluster. You need to have globally assigned IP addresses, all right, when configuring it. Features that don't work, all right, IP allow list providers and IP block list providers there. Currently, the reason why it doesn't work is because there's no real standard. They haven't come together and said, right, this will be the standard that we want. Right, so that's going to be one of the issues that you're going to go into. You got your sender reputation there. Of course, that's not going to work. You got your income, message, rate limits. That partially works, right? But if it is coming from an internal attack, it will accept all of them. External, you can at least limit it, all right? But if it comes from a local link, well, you're going to be basically get nailed. All right. Unified messaging. All right. If you're using any of those components, that does not support IPv6 there. The link here at the bottom pretty much directs you to this web article, all right, explaining everything in greater detail, all right, than what we have time here about this. Just going through a demo as well. So what I'm going to do is on my iNet server, all right, start up with, as you can see, there is my external. So if I actually go to my client side, I can, there we go. Right, I'm not the world's best web developer, as you can see. Right, so that's my intranet site there, but if I go and www.contaso.com, all right, there's my internet address, my intranet site there. So a couple of things that we want to go and do, of course, inside here is first thing, what your ISP might be doing, is go to your network adapter and under my TCP IP, go and add another address. So 0. All right. So there I go. I just want to make sure that I put the right IP in my notes. All right. So it's okay. Actually, what I'm going to do is just cheat a little bit. Copy it. Right, so that's the first thing that I want to do. I might want to go inside my DNS and create a new host record. All right, so I'm going to call it www6. All right. So just give you a clear indication of where it is. IP address, and I'm going to give it 1. And it's successfully created. All right. So now what I can go and do pretty much is on my IIS side of things there, as you can see, I currently only have the default IPv4. So under my bindings, I can say add, and under my unassigned, I will add pretty much my IP address that I want to set up inside here. Right, I can go www.6.contaso.com. So okay, right. Because I might be hosting for multiple, I don't really need to have host names inside there. The only reason why we use it is because was of the limits that we had in NT4 days. Oh, sorry, IPv4 days. Right. So if I say close here, and if I click there, I should be able to open and get access to my website. I've got a feeling I made a mistake with the IP address.
Yeah, you not have had a 1 at the end of it?
Actually, it did take it out there. So what I'm going to do... No.
Should not have a 1 at the end?
Colon 1. There we go. Colon, yeah. Thank you. It actually stripped it out. Originally, I had 2 inside there, if you remember correctly. Oops. So, all right. Copy. So if we just go back in DNS. There we go. Right, so hopefully, there we go. All right. So now we pretty much have that flexibility there. So now I can go back to my Windows machine, Windows client. And if I go 6 there, hopefully it will work. There we go. All right. So as you can see, that's pretty much what we can then do in migrating over, all right, from a website to that. Now I can go, once I've done the testing and everything works in my environment, I can go back to the ISP and say, all right, make it now a pure www record as well, so we don't need to go www6, etc. And we can then pretty much go through that process there. The last thing there is running into problems. Okay, we're running a little bit short on time, so I am not going to do the demos, unfortunately, because I don't want to keep you guys too long. If you want to see the demos, I will be available afterwards, and I will then go through that. All right, but I don't want the guys that want to go. I'm not going to keep you up. So some of the things that we need to look at. This is going to be some of the common problems we have. All right. Everybody says when you read the blogs, go and disable IPv6. By all means, go and disable it. By all means, go and disable it. And if you haven't picked up the tone there, I've been very, very sarcastic there. All right. You will break your workstation. All right. It's actually more, it should say, not how to disable IPv6, but how to break your workstation or server. Because this is what most people go and do. All right. They go into a registry hack, all right, and they disable all the components. What effect will it have on me? For those of you who are using Hyper-V clusters, there you go. No longer will we be able to add in additional cluster nodes inside there. No longer will we be able to scale out, all right, until we go and re-enable those components inside there. So Hyper-V utilizes, and clustering, of course, utilizes that there. The next thing there is TMG server, right? Although TMG itself doesn't really utilize IPv6, all right, to a great extent, but by disabling it on a TMG server, you will actually break your VPNs that you set up via it, all right? So any VPNs creations during the TMG server that some of you guys might be doing, that will no longer work. Writing and remote access breaks totally, all right? Exchange. Mail flow problems. The mail arrives, the mail doesn't arrive. The mail arrives, the mail doesn't arrive. Where's the problem? All right? Try and troubleshoot that. All right, that's not a simple one. Other things that I've experienced personally is during installation. Client went disabled IPv6 without informing me, trying to do Exchange installation, and it keeps failing on the installation of the hub transport services. The hub transport services requires IPv6 to be installed. All right? So then you need to basically enable it, do the installation again, and it will continue. Another one that has happened there is services fails. So what happens is people enable it on Exchange 2010, get it installed, and then they go back and disable it. All right? But just deselecting the IPv6 setting there. Reboot the machine. They can't understand why it takes 2, 3, all right, the longest I had is 8 hours before a service came back online. All right, it was a small business server as well saying that there, but 8 hours before I could get back to a Control-Alt-Delete just to go and enable that there, rebooted it 5 minutes from reboot to login. Okay, so look at those type of things. Other things there, direct access, all right, of course if you basically go and disable that, that no longer will work. For those of you who are using home group at home, all right, on your home workstations, disable that there. Again, that will not work either. All right. So to solve the problem, start implementing it, all right, in your own environment. Okay, so that's pretty much where you want to go through, all right, look at that there, get ready with a design, looking at your IP devices there, your operating system, your applications, etc. So that's pretty much what you want to go and do. All right, thank you very much, guys. If there is any questions, all right, feel free. If anyone wants to see the demo afterwards, all right, you're more than welcome to stay or come forward and I will show you the demo.